All right. Hi everyone. My name is Bharat Jain. I hope you're doing amazing. So this is my part, sort of my second try of doing this live stream. The first time I did it, there were some issues, but I'm trying to do this again. But today, what I'm trying to do is this is a continuation of the yesterday's live stream, where I was essentially trying to set up and use the LA robot or SO-101 arm that I have in place. And as you know, that in the last stream, I was able to completely build all the arms, including the leader arm. And today, what I wanted to do was essentially install all the softwares, calibrate everything, including the motors, the software stack, and everything else, so that we could start teleoperating and start collecting some data. So that would be very cool. And I'll show you. I'll show you. So what type of robot I'm talking about if you're joining me. So you see that these I have two of these robot sets with me, and what I could do with it essentially is that this particular one is what's called as the follower arm because it comes with the claws, and this black one that you see this here. Yeah, so the black one that you see here is essentially the leader arm because the idea is that I could use it to teleoperate or control this white arm. And the idea is that you could sort of use it to teleoperate or even perhaps collect certain episodes or data sets for it to do specific tasks, to train specific models, and that would all be very interesting. So one thing that you see here is that both of them have sort of this servo bus. Both of these sort of have that connected, and what we're going to be trying to do is that we try to calibrate all the motors that are there. So the leader arm hasn't been calibrated for the motors, so that's what I'm going to be doing first. And we're going to be giving numbers to each of these. So this is actually a 6 degree of freedom arm, which means that it comes with 6 motors. So yeah, I mean there's 6 motors here. So this one was already calibrated. This was already done, but this was not yet done. So this is absolutely new, and this has to like probably be calibrated and everything. So that's what we're going to be starting with, and hopefully we're able to do both of them perfectly, and then we can start the daily operation. All right. So if you're just joining, do make sure you say a hi. So I'll respond to all the comments that I see, and let's get started. So I'll share my screen, and okay, let's keep it like this. So what I'm going to do is that I'm going to come to the terminal, and this is the terminal, and let me just zoom in here as well. So this is the LeRobot folder that I have with me, and it contains all the files for the LeRobot. And what I need to do essentially is now I need to connect this particular leader arm with the power supply as well as to the USB or the USB-C to my computer. So you see, this is actually the servo bus which connects to all the different motors that are there, and this is one end which I need to connect to the servo bus. So let me do that. Okay, so the servo bus is connected. The next thing I need to do is I need to connect the USB as well. So let me find the USB. So there's so many wires I have. Okay, so here's the USB. Let me just use this one. Okay, so let me connect the USB here, and then after that, what I need, so you also see the power, the red line being turned on, and then I also need to connect the power socket. So this is a 5 volt, 25 watt power socket supply. I'm connecting to it. Where did I graduate? I graduated from this university called as Plaksha. It's in Chandigarh, and it's a pretty good place. You should check it out. So yeah, and okay, so you can see a red light coming here as well, and what I should do now is essentially, you can't see it, so this is actually very small. Yes, so this should be better. So you should actually see the red light coming here, and this means that the servos are connected essentially with the power supply. And what I need to do next is essentially just give numbers to each of these motors. So these are 6 motors that are connected, and each of these motors have to be numbered based on their position that they are in, right? So what I need to first do is that I'll come on LeRobot, and I'll go. I want to first find the port it is in. So I'll actually copy this command. So I'll have to zoom in properly. So basically, I'll copy this command and come here and actually do this find port. So it will list down all the available ports that I have in my computer, and if we zoom it further, so it will remove. So I need to remove the one port that's connected to this. So let me put this on the side. Yes. So it should be much more clear. And yeah, so this is actually the USB that's connected. I'll remove it, and it should probably capture that. By the way. Okay. Oh shit. So let me remove it and enter when done. Yes. So it found the particular sort of port that my thing, essentially this one is connected. So what I'll do, I'll connect back this again, and I know exactly. So I'll have to copy this particular USB port number. And what I do is that I have to come back and actually now start configuring each of the motors and give numbers to them. So there is this command that I need to do, and basically, if you see, it's a LeRobot.setup motors. So that is a command, and let's see if I can do they have it. Here, yeah, it's here. So you see this? This is the command that I need to follow it. So before that, let me just paste or let it be there. So I think it's already there. So let me just copy this and paste it here and remove the comments that is there. And here, so remove it completely. Control V. So let me remove the comment here, and then let me also replace with the actual server that I have here, which is this in this case. So let me copy this and paste it here. So this is the actual one that's connected to, and I need to use this as not the follower, but rather this is actually going to be the leader. Okay, and I believe this should be good. So let's see that if this works. Okay. This is the video, and here what we're supposed to do is just basically this, and so he starts the script, and right now nothing is connected. Okay. All right. What is the error that it shows us? Uh, okay, this is where we started. Usage. Okay, so let me first remove the bus from here, and also take this out as well. Let me actually do one thing. Let me remove everything, and let me also remove this as well. I'll actually use the other one. Okay, so I'll use this one to actually configure it. So what I'll do is what I need to do essentially is that connect it one by one. I think starting from the one from the end, right? So starting from the gripper, I need to connect it, and first I need to find the device. So it's already there. So let me just put that and connect these two connect the power jack and then the USB C to this, and then okay, which one side should I remove? One second. Let's go back here. Okay, so we have to remove this, and so I have to put everything back again. So it's going to be a bit of pain, but that's okay. I should have done that before. So remove it, and I'm just afraid of taking it. Um, yeah, it's not coming out well. Yeah. But I have to remove all of them in this case, or at least half of them. It was a pain to get in, it's pain to get out. But first, tell me this thing, if I can just start it again, what happens now? Choose one from this thing. SO-101, follower. No. Okay. This is for the follower. Where is it for the leader? Follower, leader. Yeah, there it is, right? SO-101 leader. Let me copy this and let me copy this and let me just give the exact. So let me remove this and remove this as well, and let me copy the exact port that I am in, which in this case should be here. So this is the exact port. So we copy this and paste it here. Alright, and let's enter. Yeah. So now it's started. But the next thing that we have to do is to be able to remove these wires so that we have to individually. So the gripper motor only, right? Yeah. So the gripper motor. It's, oh, okay. I got it out. I hope I didn't snatch any wires. That would be very bad. Okay, so I remove the gripper motor, and what I'll do, I'll have to put this in. Okay, so gripper motor is inside. I have to press enter. Holy shit, where is it? Okay, let me start again. Make sure it's connected. It is connected. Gripper motor. Okay, maybe the port has changed. Let us do that again. Remove the USB cable. So it's removed now. And if you press enter. Okay, so it's a different one perhaps. Yeah, it's a different one. I was copying the wrong photo. So let me just copy this and put this back here and copy the command from here. And what I could do is yes. So let's press enter. Yes. So one of them is done. So the gripper is done. So we'll have to remove it now. Okay. And so it should have probably gotten its own number. And gripper is done. Oh shit. Okay. Alright. So gripper is done. It's this one. And then I need to remove the next one, which is this. Okay, so that's also removed. And let me put this here. Okay, so this one is here. I will press enter. Okay, so that's also set. All right, remove it properly. It's removed, and then we need to get the other one out, which is this third one. Okay, and this is stuck in. Okay, let's press enter. Yes, done. This is done. Okay, so the next one we'll have to remove. Alright, we come here. Okay. So I'll remove this one as well. Okay. Okay. Perfect. Press enter. This is also done. Okay. The fifth one is out. And let me just put this here. Okay. And press enter. Alright, this is also done. The last one. Let's do this and move this one. This is the last one. Alright, all of them are done finally. So that's a good signal. Now we probably need to connect all of them back so that we could start configuring each of these motors. So I should have done this step before connecting all the wires, but that's okay. But that's okay. Okay, so I have to connect these wires back. And I think one of the things I try to do is that this screwdriver actually helps me. So I get like the flat bit out, and then that really helps me with these wires properly. Okay, let me remove this so that I don't get current. And we have to put all these wires now. I'm just afraid that if I've just like pulling them out, I would have snatched maybe one of these wires and it would all been messed up. Like I would never even know that which wire was the issue. When it's very difficult to get that back on. One second. Just try the other ones. Where is this supposed to go? The next one. This is it. Alright, this one. This one's to go here. Okay, that's one. That one is also. Let me just stop this. Yeah, there we go. Just push it over from Okay, so all of them are done. Just one of them remains. It's kind of difficult to get that properly inside this. Let's try it again. So, Yeah. Okay. I think all of them are in now properly. So that is a good signal. We should drop it. So this is kind of a bit hard to move. I don't know that's how it's supposed to be. That's okay. Okay. Okay, let's try now. So everything's done. We could now start calibrating the motors. So earlier it was not happening because I didn't do it properly. So I didn't calibrate them. And let me just put it here. So let me just put it in the this servo bus and so this is essentially LayLab where let me just see if it's live. So it's stopped. What I need to do is I need to come here. Yeah, and this should probably start LayLab, which is like a draft GUI to configure the motors and everything. All right, so yeah, you can see that it's here. So this is SO-101, and this is if I go on calibrate. Okay, so yeah, so the follower arm has been calibrated already, and I did that yesterday. What I need to do is I need to calibrate the leader arm, which is this black one. So for that, I'll plug it in now, and yeah, so the last one turns on, so that's a good signal. And let me also now give this, and let's find our USB connection. So let me remove this, and yeah, so it's detected, and let me put that back in. Yeah, so it is this one. And what if I start? Yes, finally I was able to see. So I was trying that for a lot of time and then it was not working, but now it does. So you can see that all these different sort of angle starts to come in, and these are essentially the motor angles that it is in. And what I need to do essentially to calibrate is that I need to take it to the extreme edges for the motors itself. So that's very good. Yes, thanks, Victor. Yeah, I mean, I was trying it before the stream and it was not working for some reason. I realized, oh my god, I didn't even calibrate the motors. So how it's supposed to know which motors is what. So now we can actually start doing it. So if you see, this is probably not going to work. So what I need to do is that I'll cancel this calibration, and I need to get it into a neutral position. So what that means is that I need to get all the motors in the middle angle, right? So if you see, this is all at a zero angle right now. So I need to get all these motors at their middle angle, so that yeah. So these motors have to be in the middle angle, including this gripper, and basically if you see it has its own edges, right? So it can sort of come to a certain edge. So I need to get this to the edges, and while I'm calibrating. So now let's start calibration. Yes, so you see it identified it, and let's start with the gripper. So first I need to, so let me come it here so that you can see it. Yeah, so first let me get to the extreme edge. So this is one edge. Now let me get back to this, and you see that there is a green tick on the gripper itself. So that's good. So that's a good signal. We need to do it for all these other ones. So now wrist roll. Okay. So wrist roll is this one. So let me go one side. Okay, one side is done. So let me go to the other side. Yes. So there's a green tick here. That's a good signal. So let's get back there. Let's do the wrist flex. Okay, it's this one. So let me go to the one side, and this is done. Let me go to the other side as well, and wrist flex is also done. Okay, and then the next three are there. So this is called the shoulder lift. This particular angle. So let me just go that to the one side. Let me get it back there. Okay, so elbow flex is done. So shoulder lift, the next one. Okay, let me come here. This is one edge, and then this is the other side. So shoulder lift is also done, and what I need to do is the last motor, which is the shoulder pan. Okay, so one edge is done. And let me do. Okay, so all of them are done. Perfect. So you see, all of them are done. So what I could do, I can just save calibration, and we are done. We are done with calibration. So hopefully we should be able to start teleoperation. So let me get this back here, and this is my first time that's going to be I'm teleoperating. So let me also connect this one as well. Um, So this is the leader follow arm. So the servo is here and it's gotten out. 1 second. Let me put this properly. Here. Okay. Yes. I've placed it now, so it should be in its place. And let me connect the first last servo motor to this. And what I need to do is this has already been calibrated. I just need to put the USB here so that it can communicate with my laptop. Okay, so the USB is connected. Good. Um, okay, yeah, this is probably a bit loose. 1 second. Yeah, this was not working well. Okay, fine. And let me put in the power supply. Yeah, here is a power supply. So let me put this in so that the motors are powered on as well. Yeah, power supply is here. So both of them are now connected. And yes, so let me put this again in the zero position as it is here. So if I start teleoperation, and I've not done this before, so if I move this, it should also move. So let's see how can I do that. Oh, the heck, it moved. Holy shit. Okay. Yeah, you see, this is working. It's working so well. See this. See this. I did not expect it to work so well. What do you think about this? Look at this. This is the first time I'm so surprised. This is amazing. This is insane. Wow, let me open the gripper now. Let me open the gripper. Ah, it's working like it's this is like this feels like magic, man. This is insane. See this. The first time I should have clamped this properly. I got too excited. 1 second. 1 second. 1 second. 1 second. Ah, okay. No, 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 no. Let me clamp this. Let me clamp this. Oh, okay, 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 okay. I didn't plan for this. Let me clamp this properly. Shit, man. Yeah. Kind of. Yeah, I had to be careful with this. This was shit. It's still teleoperating. I need to go back so that it's not in teleoperation anymore. And holy shit, man, that was like so smooth. That was like the smoothest shit I've ever seen. Um, okay. So if I clamp it here, will I still be able to use it? Okay, 1 second. Let me just. Yeah. So you could probably see it now. Let me clamp it. This is a big ass cable. The clamp is probably too small for this to be fit here. We have to rearrange. Um, okay. Yeah, I think I just need to clamp the follower arm properly because this one I can still handhold, hopefully. Okay, okay, it's clamped up. It's clamped up. Let me show you. Yeah, I think this is probably a better angle. And this is my leader. But the issue is that you can't see this now. I adjusted the height of that, and yeah, so I think this is pretty visible now, and both of these should be visible. Hmm. All right, this is okay, and yeah. So should I also? I think I'll just hold this so that it doesn't move, and this one seems to be clamped perfectly, firmly, I would say, and okay, let us connect that again. All right. Yes. So that is connected. Okay. There is a white balance I don't like. Okay. Perfect. Let me screen share. And yeah, you see the screen share. And I'll do is I'll start teleoperation. Oh fuck. See, automatically gave to the original position. And wait, let me actually do one thing. Is there a way where let me actually just show you how it looks. Come here. Okay, let me try to pick this up. Let me try to pick this up. So this is one thing. Let me try to see if I can pick this up. Okay, and okay, I need to come down. Okay, more come down. Okay, open the gripper. Close the gripper. Yeah, I picked my first object. See this. This is the best thing I've ever done so far in my. Look at this. Isn't this insane, guys? Look at this, and it works. It's so smooth. Like I've seen demos where it jitters, but I'm telling you, this is like so smooth. Like it's almost instantaneous. And hats off to the LeRobot team, guys. This is insane. Let me just place it somewhere, and yeah. What happens if I open the gripper? It drops. It drops. I can play with it like for hours. Actually, let me get the camera angle a bit up so that you can see that clearly. Okay. Yeah. So see this now. If you control the white one, does the black one also move? That's an interesting thing. I don't know. Let's see. Dude, this is again not pinned up. So you know what? I can't move the white one. Like the white one is just like fixed in its place, and the motors are locked. So the motors can only be moved, I think, through a servo. I can't move it forcefully, and I have to stop the teleoperation to be actually able to move the motors of the white one. So I was trying to actually move it, and it's like not. It's just locked. It's just locked by default. I have to move it using this only. Yeah, you can't move it like that, and you have to use this only. And this works better than demos because I've seen a few of the demos where I thought that it would jitter and my laptop wouldn't be able to support it, but it turns out it's perfect. It works without an issue. Let's try to pick some things. Let's try to pick some things. Let's practice how to use it. So okay, I have this thing. And I have a marker. I have a pen, and I have the screwdriver. Okay, let's try to pick it. Let's try to pick like maybe a easier object, which is like the marker. So first, let me go here, rotate this, come down. There's a technique to it. Uh, okay, I'm here. Okay, yeah, I picked it up, and the grip is pretty strong. It's able to hold it pretty well. Doesn't let it go. Let's drop it. So if I release it, you see it drop. Okay, let me try to pick some other things. Yeah, let me show. All right, this is also picked up, and can I place it somewhere? I want to place it inside this cup, inside this open cupboard. Let me drop it here. Yep, it's inside. Okay, let's pick this orange thing. But I'm not able to get to that. Let me just put it here so that it's easier for me. And okay, how do I get that? Mhm. Okay. Ah, fuck, missed it. This is hard for a human to do, man. Like, just imagine training a robot to, training a ML model to do that all by itself. It's gonna go mad. Man, this also, I'm not using this one, this particular joint. I should use this joint as well. It works so well. Look at this. Okay. And let me get this here and move this forward. Move this. It feels like I'm a JCB operator, but so terrible. Okay. Still not able to get there. Okay. Good. Yes. I guess yes. Let's go. Let's go. Let's go. Let's go. I finally have it. What do I intend to do with it? I wanna just use it, man. Like I love using it, and like, but if you were to ask me, I would actually want to use some. I want to actually train some VLA models on this, and there's a lot of interesting models that they're coming up, like VLJEPA and everything. So like all the models that get released for robotics, like these state of the art models, they get released for LeRobot support as well. So it would be pretty fun to train them and like see how it works in action. And I also want to like just see if I can make an agentic loop out of it, which means that if I can make it like just say that can you pick this object up, or maybe can you open the claw, can you close the claws, or maybe can you get to maybe like a something like this angle, right? Can you get to this angle, a straight angle? Is it possible? So can I do that? I think those things would be pretty fun to do. See this remote JCB operator, totally, man. JCB, but 6 degrees of freedom, which. I'm actually getting better at this. There was a learning curve, but I think I've gotten a hang of it. Let's go. I mean, the grip is so strong, man. Like, it's so strong. Look at this. Let's see if it can pick up this. It's very heavy tape. Let's see if it can pick up this. It does indeed. Pick up this properly. I can retain it as well. Let's put it inside the drawer. Yes. Pretty fun if you ask me. This shit is too good. Like this is just like so fun to control. And this happened all live in the stream, man. Like I didn't do this before. This is the first time I'm doing this, and so you could see the excitement on my face pretty much clearly. Let me just get this back, but my monitor disconnected. Just 1 second. Uh, what is the issue? Just this. No signal. Oh, let me remove the HDMI. Put it back in. Okay, everything got messed up. Everything got messed up. Okay. Is it back? Yeah, it's back. It is back. Okay. Also, one more interesting thing is that you could let me just screen share and show this to you. Yes. So, this is probably stopped because it got messed up. Let me start teleoperation again. No connections. The connection broke. Uh, okay. So now I have. Okay. Yes, it's back here again. Let me do this. Let me zoom into this. Holy shit. Yeah. So you could actually see this live in action as well in 3D. So see this. As I move it, it should also move. And if I open the gripper didn't came. Okay, now it's not coming for some strange reason. It was coming before. Let me refresh it. So the connection is probably broken. Let me start again. Teleoperate. Okay. Yeah. Okay, so let's zoom in here. And yeah, so you can see that it's also sending me a 3D visualization of how it's going. But this is getting cut. 1 second. Okay. Yeah. And I can move this. So this is the first joint. This is the second, third. So this is six joints are there. Okay, great. So let's see what can we do with it. So I'm just exploring here, and let's see what all fun things can we do with it. So data set. We can create a data set. We can train a models local on your machine. Okay. We can also do it on their. Can we import a model? I think we should be able to. Local jobs. Okay. You know what I'm interested in is actually seeing. So I found one GitHub repo. Let me find that. Um, SO-101. I've actually started. So if you go on my GitHub, and let me go on my stars. SO-101 inverse kinematics. When did I start it? Yeah. It's what can it do? Efficient implementations of different kinematics, keyboard control, mouse control, compute and visualize this. Yeah, I think it was this one, and I think there was this other one as well. Uh, Maybe I was checking some guy's GitHub contributions and I found it. Search it. SO-101 ARM. Okay. Robot control. This tool provides a robust framework for controlling SO-101 ARM and just flip the camera to me. Hi. So this tool provides a robust framework for controlling SO-101 ARMs, primarily through MCP server. It allows LLMs such as Claude, Gemini to interact with the control of the robot using natural language instructions or AI intervention. It also offers direct keyboard control for manual teleoperation and includes command line interface. AI agents are flexible. So what can it do? Key features: MCP server for LLM-based AI agent control, CLI AI stack for supporting this, configurable 19 GitHub stars. So I want to go to this GitHub. Use cases: developing and integrating custom AI agents, manual testing, and teleoperation. SO-101 ARM. Okay, so where is the GitHub? So this is where it is. And let's start this. Also, yeah, I think I know this guy. This guy's actually very popular on YouTube. Is it this guy only? Yeah. Yeah. I hope you can hear the audio. Can you hear the audio? Let me share it again in case you were not. Yeah.
Hey robot, I want a drink. Can you please help me? Hi, I'm Ilya, and today I will be exploring how large language models can control this robot to test the embodied reasoning capabilities. I've created an MCP server that allows any LLMs like ChatGPT or Gemini or Claude and so on, and any LLM client to control this robot with very easy plug-and-play integration by using information about the robot state and the feed from the cameras that this robot has. I primarily did it as an educational experiment, so MCP is not the best and most efficient way to control the robot. So yeah, mostly it's for the fun and some education learning. But on the way, I also explore a lot of different things like inverse kinematics of the robot, the overall implementation of keyboard control, testing of different stages of using letting MCP to control the robot. Also, I will talk about the MCP itself. So what is this protocol means, and how to use it. So I'm supposed to actually go into a lot of details that can be useful in other projects, in other ideas and implementations too. In the first part of the video, you can find a lot of interesting and useful information related to LLMs and robots. And in the end, in the second part of the video, I'll show a lot of demo of different LLMs controlling my robot. I will show both successful examples and fails, and also discuss the main fail patterns. All my code and instructions are available in the GitHub repository, so you can try it yourself at home and let me know how it goes. And now, let's begin. Let's take a moment to discuss what MCP is. MCP, or Model Context Protocol, is simply a standard
Straightforward. Doesn't even explain things by step.
and give them extra capabilities is to implement what's called MCP server. Ask LLM to generate the answer from a system, but this time, again, as this information is already in the context, with a high probability, LLM will know what to answer. Experimenting with this robot. Let's discuss how we convert position of the motors into the linear position of the robot. Let's look at this picture of my robot from the side. We can see that robot has two main links, the one called shoulder and connects this motor with this motor. The second one calls elbow and connects these two motors. And we can control the position of these links by changing either shoulder lift, this is the angle controlled by the first motor, or elbow flex, this is the angle controlled by the second motor. What we want to transform these two angles, shoulder lift and elbow flex, into the coordinates of this blue point in this system of coordinates with the x-axis on the table and the z-axis directed upward. And we want to transform both like angles to the linear position and linear positions back to the angles. The first thing that we need to pay attention to is that this physical 3D printed actual robot links are not aligned with the geometrical links that we will use in the simple modeling of how the robot works. Simply speaking, this motor connected to this motor and this motor connected to the next motor, and the actual kind of geometric link goes between the axis of the first motor and axis of the second motor, and then axis of second motor and axis of the third motor. But because of how the robot works, this actual line that connects them is not aligned with the actual link. So whenever we kind of move between the actual physical position of this link and this link, we should add or subtract some offset that should move when we we need to adjust wrist flex. But it's very simple adjustment. So basically, delta wrist flex that we need to apply is just delta alpha 2 minus delta alpha 1. And this is what we will apply for this correction in practice. I have open sourced all the code that I'm using today, and you can find.
Let's go here and let's get the code. Okay. So this is the code. LeRobot Studio. Now this is not the code. Okay. Where is it? The code. Let's come here. Yeah, this one. And let's ask it for this summary of what it is. And this is the start. This is nice. And let's just install it. It's now partially supports LeTV, only ARM. Use the robot, manage keyboard control, MCP server, AI agent. Okay. Alright. The thing is that I don't have a camera attached to it, so I don't know if it's let me see. Can it still specifically camera attached to it? Yes, the robot can still control the camera, but functionality will be limited. Like move forward 5 meters or open the gripper by let you know the camera feels unaware, then you can successfully execute. So let's go here.
Since Anthropic created the MCP standard, I expected the native desktop client will support all MCP features by default. But this wasn't the case in practice. So first of all, it doesn't support SoC transport for locally running servers at all. So it means that if you want to run your MCP server locally, you can use only STD-IO transport. It's not a big problem. So I managed to configure it. So basically I provided the path to my Python environment and the Python file so simply speaking, in our
okay, so it can work without the camera as well, so that we should be able to at least configure this and test it. And then once we have a camera, we could actually get everything there. So let me come on my terminal here, and just let me go on CD desktop, clear this, and let me go on SO-101. So I've created a folder here, SO-101. And I'm inside. Let me clear this and let me do one thing. Let me copy the link and clone this. So come here and clone this. So let me do it. Clear. Alright, this is done. And let me just go to robot MCP, clear this ls. And there's probably a UV virtual environment that's there, so I need to get the dependencies in. Okay. Yeah, so that's okay. We copy all of this and paste it here. Tip 3. Uh, yes, so tip install. Let me just move this. Let me just get this one. So tip virtual environment is not activated. So source.env. Let me just do it one by one. So Python H-O-N-E dash M VENV dot VENV. So that's the name of the virtual environment and it is created. So if I do ls minus LA, I should see a .venv created here. So then I'll have to probably start my virtual environment, then slash activate, and this also started up my virtual environment here. So if we clear it, and the next thing I need to do is to install all the requirements. So pip install dash r requirements.txt, which should install all the requirements. Okay, what is it doing? Cloning. Ah, alright. I hope it doesn't create any issues with other configurations. It's installing. Yeah, maybe the internet is a bit slow, but that's okay. NumPy. Let's understand the code as well. Let's try to see if they have a server.py here. What is the main file that they're starting from the MCP, the MCP server.py? Where is that file? Run test. Yes, this one. So it should have all the tools. Let's look at some of the tools. Get robot. Lazy initialize to global. We avoid creating controller. Okay. Get state with images. Get a description of the robot and then this instruction to the user. Run it before using any other robot. Get initial instructions. Interesting. So that gets all the instructions that are there. Get robot state. So what does it do? Get the current robot state with images from all the cameras. Return the list of objects JSON with results of to move and current state of the robot. Images from all the cameras. Interesting. So this is another tool. What is the name of this tool? Move robot. Okay, so the move robot tool move the robot with intuitive controls. Okay, so arguments: move gripper up millimeter, move gripper forward millimeter, tilt down angle. Interesting. So it takes in all these different arguments, move parameters, control gripper, graceful shutdown. Okay, so I think this is the main tool that's there, and I mean, one thing it can do is, so there is the one where for inverse kinematics, how it's doing that. Kinematics with PY, inverse kinematics, so target X and Y. Okay, so it's just calculating it. I'm just interested to see how is it taking the image and then sort of finding all the coordinates. Where is it doing that? Just ask this. And uh, from the image retrieved, from the image retrieved, from the image retrieved from the robot's camera, um, how is the LLM VLM that estimating the coordinate position of the object? It's not actually performing in specific setup. The VLLM or LLM is not actually performing a precise coordinate estimation in the traditional sense of calculating XYZ coordinates from pixel. Instead, it relies on reasoning and relative commands. Okay, how it processes work: visual reasoning. The LLM receives the raw image feed and uses it uses its internal training to identify objects like a ball or soda can and their relative location within the frame. The ball is to the left. Abstraction. The LLM translates these visual observations into human readable relative commands that move robot tool understands, such as rotate lever, move forward, or tilt gripper down. Tool execution. The actual coordinate math, the inverse kinematics, is handled by the MCP server's code, not the LM itself. When the robot decides to move the robot closer to an object, it calls the move robot function with these relative parameters, and the local code executes the motor adjustments required to achieve these movements. Essentially, the LM acts as brain. Okay, so essentially, um, if you see, this is the main code where, so let me just put this on a different row. Let's go to the move robot code. Move robot, yes. So what kind of parameters is it expecting? And this is the description of all the parameters. So the move gripper up millimeter. So, for example, if I have a robot and I want to move it up, right? Move the gripper up by which millimeter? So once this millimeter has been given, does it then sort of call another tool? Float. Okay, move parameters. So actual move parameters. And where is it finally getting the moving parameters, and how is it sending those commands? Move gripper up millimeter. Okay. So if they're not given, it's not storing it. It's not none, else none. Filter out none values to pass only specified arguments for the robot controller. So it just moves any none values. If not actual parameters. So if the entire thing is not none, then what you do is you can just get the current robot.get current robot state. So that's essentially getting the coordinates of the current robot. Then current state result to JSON. No movement parameters provided. Okay, so this is probably in the case where none of them are provided, and this returns the state. But if they are provided, then what does it do? Execute intuitive move, actual move parameter. So let's see where this is. Let's refer this function, execute, and then control F. Okay. What is robot object? Robot object, where is it defined? We search for robot, robot controller, robot config, robot, right? This is the one. So robot controller is essentially my robot object, and robot controller, right? So this is where it's coming from. So if I come on here and robot controller, if I go to that file, this one, okay, and what is the name of the function that I'm using? So the name of the function is robot.execute intuitive move. Let's search for this. So copy the name of it. Let me copy this name. Oh yeah, yeah. This file, robot controller. Okay, yeah, there it is. So this is the main thing, and this takes in all the parameters that are passed by the LLM on how much distance it has to move. Use interpolation, execute intuitive commands, domain control, read only, okay, target position, okay, target X and target Y. So move gripper up is not none, or move gripper forward is not none. So target X. So partition millimeter plus this thing by how much? So target. Okay, so you find the target, and then essentially, okay, yeah, that makes sense. So basically, what you're doing is that you find the current position. So this is finding the current position, and what is it doing? You have a Discord. Hi, yes, you just comment here now. So you can message me on LinkedIn. You can find my find it on the you can message me on LinkedIn or on X, or I think I should reply to you there, and we can probably connect there. I'm trying to set up a Discord very soon. I'll do that. Let me know what you're trying to build, because so I'll show you. Maybe you cannot see the SO-101 arm, but yeah, this is the arm, and this is the leader arm, and this is sort of the follower arm. Right now the teleoperation is off, but I just like to scroll back there, and you should be able to see the teleoperation in action. I'm just trying to make it agentic right now. Oh, that's insane, man! I'm right here working on it. That's insane, man. That is actually insane. So you're working on the SO-101 now? What are you doing? Are you training any ML models in this? Let me know which models you're training. Because I was able to finally complete it today and then finally get the teleoperation working thing today. I was trying to make it work for like a few days. Yeah. Uh, yeah, sure. Right now working with the company right now, but that contract is ending soon. So maybe if you can just connect with me on LinkedIn, I'll love to have a chat. Can we do a Google Meet? I'm working on SO-100. That's insane, man. So yeah, let me actually complete the stream. Just message me on LinkedIn, and let's get on a meeting. Let's get on a meeting as soon as possible. That would be insane. Yeah. I'll just send me a request on LinkedIn, and I'll text you there. Yes, thanks. And let me just come here. Yes. Okay. Yeah, so this is pretty interesting, right? So what they're doing is that essentially this is the main function that is doing everything, and they're just getting the target position, and this is the current position of the robot, where which is being retrieved. This is what the LLM gave, for example, an estimate of how much to move, and then that target is then, I believe, going to the inverse kinematics. Yeah, so this is basically going to the inverse kinematics and getting all the sort of positions of the motors to be able to get that. And that is something that the LM doesn't have to touch. So that's an abstracted layer that the LM does not have to touch, and it could probably just do that very easily. So let's see if it has been installed. Yes. So all the libraries have been installed. Let me clear this. All right, and let me come here. So the virtual environment is activated. Let me clear this. And what is the next step? Let me come on the README, and yeah, alright. Install dependencies. That's what I've done. Update the config.py with your serial code of the arm. So I need to find those arms. So where is the config.py? Let's do a ls, and so there's this config.py. Let's do them config.py. Okay, and why is it like this? Why is it uncollected? All right. So where is the okay? Yeah, so these are the serial ports. And my question is it for the leader arm or is it for the follower arm? And default remote IP. It is probably for the like yeah, it's probably for the follower arm, right? Like because leader arm is irrelevant in this case. So what? Let me just find that. So how to find that? So there's actually I have to come here, and this is the LeRobot thing, and there's actually a function that they have, which is to LeRobot find port, right? So this is LeRobot find port that I need to use, and let me zoom this in. Oh, this is so difficult to upload. Okay. Fine. Let me also switch the cameras to this, and let me come here. Yeah. So basically, you see, let me remove this USB, and it should be able to find me the port that I am in right now. LeRobot, go up, find port. Yes, this one. So finding all the available ports, let me remove it now. So it's removed, and let me press enter. Okay, so this is the port that I am looking forward to. So let me copy this, and let me put the port like connection back in. Alright, so this is done. Let me just come back to the agent menu. Yes, so I have to replace this with it. So let me go this DW. Okay, yes. Come on the insert mode. Paste this. Yeah, that's what I paste. Copy. Paste. Yes. Okay. Inverted comma. I inverted comma. And let me come here and let me put this. Okay. So this is probably the port that it is in right now. And yeah, this is good enough. Alright, let me just do cat config.ui just to make sure that everything's here. Uh, yeah. So 5591 and 591. Yes, it is this one only. Is there any other changes that we need to make to the configuration and the robot IP? Uh, for the okay, no, that's not the case. Connect cameras. So I don't have camera right now. Or wait, do I? Maybe I have the camera this one, but yeah, let me actually connect the camera. Let's see how can I do that. But let me just see if everything's working. So check the robot status and calibrations. Let me just run this and go to the terminal and use this command. So it's checking the positions. Okay. Alright, what is it saying? No module name LeRobot SO-101 follower. Robot MCP check positions. Okay. Why did it install it? Module not found. LeRobot SO-101 but I installed all the libraries. So tell me this thing. So this is probably for SO-100, and I have a SO-101. Is it not going to work? Like the LinkedIn link is not working. Let me just send this to you here. It should hopefully work. Yeah, this should hopefully work. And yeah, all right. Let me just come here and this. All right, yeah. All right, and yeah. So my thing. So you were using SO-100, right? Tell me the difference in SO-100 versus the 101. Because I think this library is for SO-100 and I'm using the SO-101. What is the difference between SO-100 and SO-101? Okay, the main difference. But let me just do one thing. Let me just do codecs here and let it figure it out. What is the version? Skip. Install the new version. I mean, there would be a few library changes, I believe. When all right, here it is. Codecs. Come here. Here is the command. Let me copy it. Check positions.py. Okay, so basically the motors are better, I guess. Really, the thing is, this thing is, so when I run this, for example, I run this command from the library. Yeah, so see this, no module name, LeRobots, robotics, SO-101 follow.py. Why do I get this? Even if I have done all the requirements, so let me just do that again, in case if there are some requirements that got missed. So if I do pip3 install, requirements.txt. Alright, so all of these requirements are here now, and let me just check positions.py, and it gives me an error. LeRobots.robots. Um, is it because I have running it from this directory? Because I already have a LeRobot folder. So if I do ls, so you see LeRobot is already here. So if I do LeRobot, do I have SO-101.robots? Is there a robots folder? No, there isn't. CD.dot. Let's come to the robot MCP and let's see what it is. Uh, where is it sourcing it from? Where is this file coming from? And robot controller import robots. Let's look at the README ones. It may be required to install LeRobot separately. Just use the official LeRobot repository. Let me just do one thing. I think everything's already in place. Let me just ask Codex to change it for SO101. Okay, so let's, because I already have the libraries and everything for it. So this library for MCP is for SO100. I have SO101. Can you make all the changes so that it works with that version? Also, let me give it the error message that I was getting when I run this. This is the error that I'm getting. Please, once done, verify. Okay, this is good. And let me do one thing. Let me just copy this and use codex. I need to give it full permissions. Okay, give it permissions for access. Yes. Let me do this now. And this is the best model actually. It's extra high, so it should be able to figure it out and do everything pretty quickly. Because if you're able to, I'm not able to see your request if you have sent it to me on my record. Okay. All right. Let's wait for it to cook and. Probably have to configure all of this. Why? It's asking you to buy premium to send a request. I don't think so. I mean, if you send me a note, I think then you have to. Or we have sent too many requests. Just send me your link, and I'll follow you. It's fine. Or maybe just follow. Just send me on X actually. Let me send you my Twitter if you're there, or maybe just follow me on Twitter. It's fine. You can Send it to me here. So yeah, this one should also work as well. All right. Let's start the teleoperation again. It was pretty interesting. Yeah. Okay. So let me just turn the camera here. Yes. Wait. Can't see this. Oh, that's insane, man. Okay. Let me just. Can I do 50-50 of this? Why isn't this visible? Yeah. Let me just do full yes. But this worked like so better than expected because like the motions are so smooth. You see this? Like I didn't expected this. So I mean I was expecting some jitterness when I would have teleoperated, but it worked like so perfectly well, and I was even able to like pick up different objects as well. So let me try to pick up this marker. So put it here, and let me just come here. It requires kind of like a practice, but like once you get it, it's kind of easy. Or not easy, but like still it's yes. See this? This is pretty good, huh? Works so well. Let me actually drop it inside my drawer. Yep. Now inside it. Pretty good, huh? Let's come back. Okay. I think it has cooked finally something. Alright. It's done I guess. So updated this. Imports now use this. Accepts the new word format. Okay. Has it created a new folder for it or what has it done? It has updated the older versions. So let me do one thing, let the codecs run here and you see this all the positions also coming here as well. And let me do let me go inside robot MCP and let me clear this. Okay. So what is the name of the file that I'm first trying to run? Uh, okay, let me first activate the virtual environment. So source pdnp will activate, clear this, and Python check positions. Let's see this works. Connecting to the robot. Move your robot manually to see position updates. Okay. What does that mean? Read only mode. Error during position monitoring timeout waiting for leak AV host to expire. Make sure the robot is connected to the correct port. Check that no other program is using the robot. Yeah, one program is using that robot. Let me just stop this. So this is the teleoperation node that's running, and this should also probably stop the lay lab as well. So if I hit refresh, it should go over. That's okay. So I stop this and check the USB connection. Verify the robot is power on. Check there's no program using it. Okay, so that's okay. And let me just clear this. Run it again. Check positions.py. Connecting. Yeah, it's still failed. What is the issue? Hang on a minute. Oh, the thing is, it's still locked. So I think I had to stop that. I didn't stop it. The robot is locked. Probably to stop it from here itself. Need to start lab again. So teleoperation. And so teleoperation is working. You come here. Yeah, so now it's free. So the robot, the follower is free now. And what I could do now is I could stop the safely and come back here again, and let's run this again. Okay, probably giving me an issue again. Uh, let's do one thing. Let's send this to codecs to debug. Maybe it could be like a maybe it could be a software issue as well. Uh, no program is robot currently. Please verify um, and debug. Let's give it this here. I mean, even if I'm able to agentically open and close a claw, if I tell it in natural language, I mean that would be a success for me for today. Like honestly, and I think it's not that hard. It shouldn't be that hard, honestly. But yeah, it has to be reliable. It has to be reliable. It can't work otherwise. And also, I'm not using this leaky wheel, right? What is this leaky wheel? I don't know. This is LeRobot. How is it different? I am not using leaky. Uh, LeRobot is connected to my robot is connected to my computer locally. Uh, yeah. So what does it say? The code is now using the local SO-101 path. The next camera initialization not TB only needs to join state but SO follower conflict. Okay. So what did it even verify? The one shot used to simply the local SO-101 and different joint values. Only the no camera paths are working. I'm using a bounded rack. Need to confirm this. Okay. The actual monitor loop starts and keep running. The bounded run killed it after 5 seconds, which is expected for a continuous monitor. I'm looking for the final diff, and I can summarize exactly what changed. Okay, fixed and verified your local connectivity. So configured POI was initially set to DKB, so I tried to connect it to remote local TP. Yeah, so check position does not need the cameras, but the robot configure was making this. Alright, let's now try to run this then. Oh, it did work. That's insane. It's insane. Let me just change some of the values. Yeah, you see the values been changing, and it's actually in real time. So if I can show it to you from a different camera, yeah. 1 second. Uh, yeah, this is probably flipping out, but let me get it here. But you see this, the gripper one actually changes its value. So the thing is that its connection is okay. So we could now sort of move forward to other things as well. So at least the connections are built in properly. That is great. Let's now try to go move forward. Manual keyboard control. So let's try to run this. This is very interesting. Press Control C. Manual keyboard control. Let's see what we can do with this. Okay, connecting. Yeah, just give an error. failed to capture. I think the reason is that let me just configure the camera as well. If I configure the camera, I believe how can I configure the camera? Because a lot of his files are kind of dependent on the camera itself, so maybe I've not given it to the configurations file, and that's why it's failing. So let me clear it. And if I go on the configure TY, is there a camera here? For different camera, set it camera configurations constant. Default camera FPS. Where is the camera name? Let's try not doing it here. Index or path is 0. Yeah, that's the question, right? Like it's probably -1 or something. LeRobot find cameras, open CV. Let's do that. Where is the LeRobot? Here. Okay, let me come to desktop, SO-101. So let me clear this and LS. So let me go on LeRobot and let me source the virtual environment. Copy and bin slash activate. Clear this. Let's run this to find all the cameras. Holy shit, what is this? Okay, so it detected 3 cameras, although I have only 2. But image is safe here. Okay, let me open this in the folder. Uh, Come here. So this is the outputs. And if I come on outputs, captured images, you open this folder. Yeah, so you can see all the cameras. Yes, so it's probably this one which I need to use. So it is a 01, right? OpenCV 0. So that's the camera that I have right now, which is my webcam. Yeah, and this is the scan. So probably let me just say that I am using the camera ID 0. Please put that in all the configurations. Configs. Also, I'm facing this error here in this file, keyboard control. So let me run this again. And so when I run this, let me give that error to Codex as well. Yeah, so this is the issue. I think it probably has to do that. Yeah, it's using the camera one, right? The camera one doesn't. Probably that issue. So let me just again, anyways, just give it to Codex, and I'll visit to the camera with the ID 51. This is also an error. This thing. Okay, let's go with this. Get back to FaceTime. Yeah. Hi, God. The current config still has 3 cameras, which is why the keyboard controller failed since you only have one camera. Oh, okay. So probably I need to get few cameras. So, Gar, if you're there on the stream, can you tell me which cameras are you using for your LeRobot? LeRobot SO-101 cameras. Overhead camera. Let's see this. So overhead camera 32 by 32 camera module. Can I find this? Is this available somewhere? Do I have to camera audio? Does it even matter which camera I'm using as long as it's a camera that I can look at? 2 megapixel resolution, 30 FPS, comes with a 3-meter USB cable. That's it, right? This is the best recommended model. 120 degree of freedom for Raspberry Pi. Um, can I reverse search this? Chat should be really find it. Just find this exact camera icon in India. Let it do the job. Okay, okay, it's done. Alright, let's test again. Alright, connecting keyboard controller terminal will like, okay, let's allow this on settings. Let's do this permissions. Terminal probably has to fill it. It's okay. You open terminal again. Yeah, backward. Alright, I'll have to okay. So let me now run the Python file, keyboard control. Okay, what can it do? So QE. Yes, it works, it works. Let me show it to you. So, how can I do this? Yeah, so you could see this. So basically, if I press Q or E, it should open and close, right? So if I'm pressing Q now, and see it open. Isn't that amazing? Let me press E, and it closes. Look at this. Q, it opens. E, it closes. And yeah, I mean, once it's completely closed, it gives me an error. What else? So there's controls for everything. Report W, right? So let's start W. Yeah, so it's moving forward. So yes, it's a bit jittery, but it's able to do. It's doing it well. It's doing it well. I hope you see this. And I probably want to make it up. So yeah, so see this, it's going up. This works so well. This works so well. What else? A. Let me type A. Yeah, so A rotates the grip, rest of this, and D is rotates to the other side. and R, right? So R will sort of move its wrist. So this works so well. And I do F, so F should get it back. So how do I move this one? Yeah, see this. Let's actually try to pick something up using this. Uh, I want to pick up, maybe let's pick up this thing here. Let me see. Yeah, so let's pick it up here, and let's try to pick it up just using a keyboard control. So let's get this here, close here, and let me get it down. Okay, this is down. I need to probably move it forward a bit now. So how do I do that? Okay, this one, do that. On and F. We put up and down. Here. How do I get it down? There's not all the joints I believe that are configured for this. 1, 2, 3, 4, 5, 6. This is all the joints. Yeah, this is the one that I was talking about. And I don't know. Keep it going down. Keep it going down. Let's go back up again. Good. And I'm going to rotate this now. Not the one. Let me just get this to this and dude, this thing is telling me that motivating this reference. It's too hard to look and do it at the same time. Yes. Can I do 50-50 of this and this? Let me bring that out and put this here, put this here. Yeah. Okay, let me reduce the size of this. Holy shit. Dude, the inverse kinematic engine is so good in this. C means camera snapshot, gripper. E. This closes the gripper. Q. This opens it up. D. I don't know what D is doing. A. Rotates it up. So I need to get it here. So let's rotate it a bit and then make it move forward. Yeah, it's coming here. Show you more. So A is making it so we make it move forward. So this is coming down. Okay, so the maximum has reached. How do I get it down? Man? F. Yeah. Okay. So F is probably here. A, F wrist flex, right? This is another one. R. S. W. Yes, that's probably the command I was looking for. Okay, how do I close this now? Press A. This rotates it. It's kind of hard to control it, like not knowing which one is doing what. Okay. And maybe let me just ask this. Um, Simply just with the joint number. So gripper is 6 and how to remove it with the sides. I remove it both the sides. Alright. Uh, Maybe in a simple line. But I don't know what is doing what. So let's get this first. Man, hi. Thanks for joining. But I mean, just look at my last stream. I was just building this last stream. Like I probably spent like 4 5 hours building all of this, and like I'm learning it right now. Like I don't know all of this, so I think you just definitely just get started with it and figure it out along the way. And AI is there to help you out, honestly. So that's what I'm doing. Okay. So CCW joint one shoulder lift. Okay, so let's get it forward. And let me just come back here so that you can see it. All right. So yes, and how do I get it? Okay. Lift up, elbow flex. I'm probably going to move the second joint, not the fifth one. Yeah, this one moves forward. Get it here. This is a max that it can extend to. What is it? I think yeah, that's the issue, right? Like, it's not able to get it to the full extent. Maybe teleoperation was able to do it, but this only restricts itself to 30 degrees. That's why I was thinking like why it's not working well. But let's try to see, and let's see if this second one can move forward. So what is the okay, so lift down? Yeah, okay, this is there, and the third one. Plus angle bond flex. How to get the third one to move? Oh, shit. So back there again. This is a pain to get in. But actually, let me just stop it here because this can probably do the keyboard control, and I don't want to do it. Maybe I want AI to do it now. So, but I was just wanted to check if it's able to do it properly. But it's actually working well. So one of the things that you see is, in order for it to do that, because it's not being teleoperated, what's happening is that there are some pre-recorded things, and then the motor values are then given using inverse kinematics, and the engine is working pretty well. That it can confirm. So at least I can use it for now, and then I can connect the MCP part to an agent to be able to do that. Yeah. So let me just actually yeah, I'll check your message. I'll check your message. Actually, you know what? Just let me finish this up, and I mean, you can come on stream. I'll send you a link. I'll come on stream as well. So let me, if you're there by that time, let me just go here and share screen with you. So yeah, now I want to. So this is probably working. So I just wanted to make test this, and let me come here. Yes, yes. So let me come here, and where is the? So I just want to connect the MCP with it. Okay. I also want to see if it can capture anything. So has the camera been configured? So if I do see, so camera snapshot saved. Where is it saved? It's probably in one of the folders. So let me go there. Where is it? Let me go on my folders and captured images. LeRobot. Okay, let me go on my desktop and then SO-101. If I go on this thing, so robot MCP, camera snapshots. Okay, yeah. So it's probably has the right camera. Probably has the right camera. Yeah, you see this? So yeah, so this is good. Now let's do one thing. Let's actually connect the MCP with this and see if robot can, like, or the LM can control it. So MCP server in dev mode. Final test step: to debug the MCP server, use the UI. Okay. Using this MCP server itself is free, but requires MCP client that will send multiple requests. Connecting MCP. Yeah, let's do this, right. Let's do one thing. Let's ask Codex to connect the MCP, and let me stop this so that it stops moving and everything. And let me just give it connect this to Codex MCP, play robot thing. I have verified the rest of the things. The rest of the things. Okay. Yes, proceed. And let it cook. Okay. Yes. I mean, if I can probably ask it to, for example, pick this object up, and I don't know how much time it takes. I mean, I don't care about the number of tries, but even if it takes like 100 tries, I let it do it, right? Like, let's see if it can figure it out how to pick it up, and if it does that, even after like some time, that's still very good. That's still very good because the camera is up there on top, and yeah, let's see if it's able to do that. I'm just waiting for the MCQ to get connected with Codex because everything I've tested so far, and it's working well. So probably yes, it's done now. What is it saying? You have less than 10%. So I probably have to keep the current model. Yes, man. Let's keep doing this. And let me do one thing, right? Let me just reset this. There were some reset functions that are there. Let me do one thing, right? Like, or concise compact. Yeah. So this probably reduces the context for Codex. Otherwise, I'm using the fast one also, so that's why that's consuming it very quickly. Um, or I can actually go on my Codex app and reset it from there. So let me go on Codex and reset my limits from there. Hold on. Yeah. So how can I? Yeah, so let me reset it and reset usage. Yeah, so I've reset it. So now hopefully it should not give us an issue. And also let me just stop this and start Codex again, so that it's a fresh context this time. Okay, and yeah, it should probably discover the MCP server. So let's ask it first about what MCP servers are available. AVARLABLE. Right, starting the MCP servers. Okay. Yes. Okay. Okay. Allow. What is that? Alright. Yeah. SO-101 arm is there, right? So can you find the okay? So let me just switch to that camera angle so that you can see the thing happening. And then get it here. But this menu is bigger. Yeah. So you could probably see the gripper. So just move it here. Yeah, you can. So now you can see the gripper. So I'll just ask it. Can you close the gripper completely of the SO-101 arm? Okay, let's see if it can do that. Okay, always allow. Okay, always allow. Let's see this. It's fully closed. Well, it is not. Okay, why is that the issue? Let me come on this and see it. Open this, and this terminal can come here as well. And this can come here so that it's easy for me to use. Okay. So the SO-101 arm is fully closed, which is not true. Uh, what is the current position of the SO-101 arm? Tell me the gripper position. And let me fully extend this gripper. Oh, so it's locked. I don't know why, but I think probably it has taken control, so that's why. Always allow. Okay, so it's getting it. Okay, close it. Okay, maybe make it move somewhere. Like okay, make the arm move. Any movement is okay. I just want to see if it works. Okay, let's allow for this session. Yes, it did move something. It did move. Perfect. Okay. Open the gripper mode. Let's check if that's working. So you should probably see the gripper changing its course. Yeah. Okay, so the gripper got completely opened. Do you see that? That was the same. Uh, close the gripper. Close the gripper completely. and let me just show this. So the codex is doing its thing, and it closed it all by itself. I didn't use anything. It was just codex working on it. Okay, and so and I can probably see. So let's see. There's a camera on top of it. What do you see? Is camera probably on top of it? Yeah. What does it say? Yes. Nearby yellow object, so yellow roll of tape. So can I ask it to pick this yellow roll of tape? So I'm putting it here. So I don't know if you can see this, but yeah, I'm putting it here. And let me ask it that if you can create, can you pick up the yellow roll of tape? Yes. So I've asked it to pick up the yellow roll of tape, and if it is able to do that, then it's done, guys. Then it's done. And I mean, I'm assuming it to do a lot of tool calls, a lot of trial and error. But I mean, I'm okay with it. I'm okay with it as long as it's able to do the task. Yeah, it's open. It opened the clock. So now it's again looking at the image and it's verifying. So it's a very reactive system. Uh, it probably has to go back and forth a lot of times to be able to do that because it's using an LLM and it's using one of the state of the art LLM right now. Okay, so it's closing it now. I don't know why. Okay, so also one of the things I mean I have to give it to it is that it's not a very good angle to be honest. So if I were to show you completely, this is exactly what the robot is seeing. Like it's exactly what LM is seeing. Yeah, it seems to be just opening and closing. I mean that's not very impressive. Yeah, I'm not moving it. Just so you know. Has it made any progress? Let's see. Let's look at the logs. Let's see what is it trying to do. The tape appears to have come up with the gripper. I'm adding a small extra lift to clear it from the table before it rests down. I think maybe it's distorted a lot because ideally the camera should also be placed in the on the robot itself so that it can have a good view of it. But yeah, I think it doesn't. It I probably doesn't have the perception of depth as such. Okay, so let me help it. Uh, the tape is placed on the table, so you need to bend it down. Okay, let me actually get the tape here. It's much more closer. So let me get it actually in the direct side of this. So this is now actually in the direct, just below where it is, and yeah. And I think it should also be capturing all the images at this time. Let's see what images has it captured. Okay, so these are the images that it has captured. Okay. Let's see. Let's wait for this to complete. And if you're there on the stream, what I'll do, I'll drop the link of the of StreamYard on the chat, so you can also join if you want to come on the stream, and we could also discuss how it was. I think Garv is here. I mean, if anybody else also wants to comment, I can add you here as well. But yeah, let's see if this is able to do. Yeah. Yeah. Let me do something better. What if I ask it to pick up this water bottle, like because it's not kept on the table, and I see that there is some limitations of, um, yeah, uh, okay, so it's completely rotated it now. So let me just, No, no. So you just try to join this from your browser, and you can come in. Okay. It does not have enough torque for that. I mean, the bottle is empty and it's quite light, but I get it. Yeah. I mean, I think one of the things that one of the issues I feel like is also because in this library, it's also doesn't have the full range of motion for the motors. It's kind of like only 30 degrees, I think, up to something. Yeah, yeah, I've clamped it. I've clamped it, man. This one is not clamped. This is what I'm using, but this one is clamped. If you look back, actually, I dropped it. So in the beginning, once it started teleoperating, I got too excited, and then and then because it was not clamped, it was like it fell off. So I had to clamp it properly, but it's clamped now. Yeah, it's doing something. I think it's probably going to burn away all my tokens for today, but it's not going to pick up the object. Yeah. No, I think I'm very fortunate, man. Like honestly, I was very fortunate. Like it kind of dropped on me, and I mean, I've also dropped it once from my table, but like I had zero expectations it would work. But like hopefully, like luckily, it's still working right now, so that's good. Yeah, I don't think this is gonna do it. Maybe I have to give it some easier tasks. Because I think the issue is that I'll tell you is because even I was not able to get it up till here, right? Because it kind of has its own restrictions. But that's the thing. Let me just give it this to this, and no, it's not a good idea. Can I do something like so you are an and say hi to me or greet me? Wouldn't that be fun? Let's see. Let's see how does it do that. You're reprinting it. You have the 3D printer, or do you get it from somewhere? Okay. Hi guys.
How's you? You know,
1 second.
I'm good. Okay, here you go. So we have my robot here. You can
Yeah.
see this, and I just broke the other one, the trainer one. So this one is with the clamps, and I just broke the clamps for the other ones, which are like here. I'm reprinting them now. Okay, they are yet to be completed. So it is only 40% done. So I'll have to redo the other arm, which is the trainer arm. Basically, the guider
How
arm
did you
is
break?
one.
How did you break it?
I clamped it too hard.
What do you mean by that? I mean, I've stamped it too hard right now.
I don't know. I just these are the clamps, right? So I was clamping it, and they shot out.
Right.
It exploded. So I'm here right now in my office. I'm working on multiple projects and multiple robots right now. So
Yeah,
as you
sure.
can
No.
see, we have a smaller one. So this one is a obstacle avoidance tank robot. It is basically for kids so that they can learn how Arduino's motor drivers and everything else works. Then obviously we have some drones. So this is a normal hexacopter. It can lift up to 4 kg. Then we have the spider robot. See, this one is very interesting, by the way. I can turn it on right now with the remote. I'll show you. Okay. So we have this, right? By the way, can you hear me properly?
I can hear you. I can hear you. Yeah.
Okay. Were you expecting to see these many robots in like a
No, I
single
was not.
screen? Okay, it's fine. So we'll just turn it on right now. Okay, so it's on. Okay. Now I have this PS4 controller which we have, I'll linked with this. I'll just turn it on. I'll change the modes to control this. Okay. And
Okay.
it can do much more. It can come to you, it can go back, it can go left, it can go right. Yeah, it can do a lot more. It can also dance, by the way.
Okay. Show me.
Sure.
So did you 3D print this yourself, or like did you get it as a?
No, so basically this particular one is all of it is metal, sheet metal. But yes, we
Right.
do 3D print, and we also work on laser cut robots. We cut them ourselves, even the metal ones. So yeah, we do that stuff.
And this spider one, was this like, did you train a RL policy on it, or like was this open source where you had to just download a program to like
No, be
how did you
so
configure it?
it is a or see it came with a pre-programmed controller, so we did not do much. But yes, we will reprogram it. So we were waiting for tomorrow because I just received it today only. So yeah,
Okay.
even I have not experimented that much on it. So we still have the boxes out there lying around in the office. I'm yet to clean it up and just come to this.
Yeah. Thanks for joining the stream. And how did you find, like, did you it was the first time that you saw my channel, or like was it before
No,
from someone
I
else?
just I was just setting up the robotic farm, and I was like, I was having, I don't
Yeah.
have a very capable system, so I cannot run any models on that, obviously. Plus, my system is so incapable of doing all this stuff. See, I have a PC at home, but in the office, I have to carry this system. It is so incapable, it cannot even keep up like 15, 14 tabs open, which you do need to program a robot like that, right?
Yeah. So,
So
so
I
what
was
models?
having
What
some.
models were you did you try it on this LeRobot right now?
No, I just jumped in, dude. I just jumped in. I have not tried any models as of now. My
Yeah,
if only if my PC would have allowed me, I would have tried. But okay, that is why I just went on to YouTube and I was like, I was trying to find the simplest model so I can at least get it moving.
yeah. So did you try teleoperation? Is it working?
No, I'm yet to plug it in. By the way,
Okay, okay. No, teleoperation is working for my even my computer is not very high. Like I'm using a MacBook Air M1, but that's what even I
that's
was thinking
very.
that what.
I'm using an i3 with 8 GB RAM. Like, come on, cut me some slack. That too, even 11. That is, I guess, 11 gen it is. 11 or 10 gen.
Okay, okay. Yeah, but I think LeRobot. I was just checking. I mean, you can, if I think if it's decently enough, then you can train models from their like virtual machines or something like that. You don't need your own GPUs. I think I'll just try to see if that can happen. I can make it work.
I'll be very honest, I come from a mechanical background. I'm not that skilled in when it comes to
Yeah,
software. Even terms like, models and stuff, they are like very new to me as of now. See, I'm trying to explore things, but yes, it is a very vast, uh, universe. It is a universe in itself, the terminologies and stuff, right? So it will take me some time no matter what.
so what are you doing with your company right now?
So we are into edtech, we are into renewable energy, we are into a lot of things, and we have bigger clients. So right now I'm working for Cyropnics Technology Private Limited. I'm here on contractual basis, but I have my own company which is called UO Intra Technology Private Limited. So we used to be in, I mean, we still are. when I was mainly working back there. Now I'm mainly working here, and that as a side stream. So when I was mainly working there, we were into edtech. So it was my duty to manage clients, and basically our USP was you can point on anything on the internet, and we'll be able to replicate it for you. See, uh, my forte is CAD design and manufacturing. See, you can point on anything on the internet. It can be a picture, a plastic part, a sheet metal part, 3D printed thing, SLA, SLS, anything. I am able to manufacture it. So that is my forte. Then I had my partner who's taking care of the software thing. Then we have one partner who used to manage our businesses. So as of now, I'm working for Teleoperation Technology Private Limited, but I'm here on a contractual basis.
Great, man. I mean, just I think just seeing you working in these labs is pretty amazing. I mean, that's why you're here till
I mean,
like what time is it? Like
it's a
almost 10,
office.
10.
I mean,
I
it's
can
been
see
a
the love.
rainy day. Otherwise,
Yeah.
yes, I do love it. I mean, I
Yeah.
enjoy it.
Yeah. Totally.
I mean, when you are a nerd and when you get to have, access to
Yeah.
all of these things, right?
What else
Plus,
do you
I'm
need?
getting paid for it, so why not? Dude, come
Yeah.
on, like, why
Yeah.
would I
Yeah.
not?
Exactly. Exactly. No. No. Yeah. I mean. Even same here, right? Like I love. Abhi to I'm just. I have this one robot. I mean, this one UGV robot I have. Like I bought it from Share, and it comes with like a lot of lidar sensors. I'm not. I'm not. I don't come from a robotics background,
Are you
but
talking
I.
about the RAS Pro?
No, no. I'll show you.
Wait, I'll bring mine.
Okay.
Is this the
Yeah,
one you're
yeah,
talking
yeah.
about?
No, no, no. It's pretty similar. It's pretty similar. So I'll show you. So this is mine, and one second.
Oh, it
This
is
is
the
like six.
RAS Pro.
No, no. This is six. Oh, this is from Waveshare only. No,
Yeah,
this
this
is
is
just
from
60.
Waveshare only.
Yeah,
Yeah.
I think pretty much similar design, but yeah, I think so. So what do you have a depth camera? Is no, or what sensors do you
I
have?
know we have a normal cam. I don't think this is a depth cam.
Yeah,
No, it's more like a normal cam, but
yeah,
it functions pretty well, dude. It can
yeah, yeah,
recognize
yeah.
faces, recognize people. You know, all of this on this Raspberry Pi, pretty amazing.
Insane, insane. I think pretty much functionally wise it should be the same, right? Like
Yeah,
I
it
mean,
is. It is.
yeah. But yeah, I mean this like the device, I like it because I mean I was actually planning to buy a TotalBot, but then
Yeah,
TotalBot 4, if you see, it actually uses a Roomba based like base, right? And
yeah,
Roomba
yeah.
ran out, like they went bankrupt, so I was not able to source it, and that was probably good because that was being very expensive for me. So rather I was able to
Yeah,
purchase it, and I feel like that's
all
like
of
much
see,
better choice.
and none of this is mine. All of this is owned by the company, but I'm just allowed to work on these because
Yeah,
obviously
yeah,
I'm in the
yeah.
R&D department.
Crazy. Where are you? Where are you based at right now?
We are based out of Noida.
Okay, that's good. That's good. Yeah. There's a lot of robotics communities in Bangalore. I feel like they're coming up. I,
So you are in Bangalore right now.
no, no, no. I'm not in Bangalore. I was in Bangalore actually. I'm working remotely, so I'm in my hometown. It's in Kanpur. Yeah, UP
Okay.
only. Yeah,
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 it's nice. It must have felt nice, to be at home and to enjoy all these robots.
yeah.
I
Yeah,
see I'm
yeah.
allowed to, take them home, but only for work purposes. So I'll be heading home very soon. As soon as that print completes, I'll be taking all of these robots. I'll take them to my home.
Amazing, man.
I mean,
Yeah.
so I have done my degree in robotics only. So all of this, I've been doing it for like 4 years, I guess. But see, the manufacturing part is that enormous and that deep that I had little to no time for software. So I guess your forte is software, I guess, because
I think I didn't.
the terminals
Yeah.
you have shown in the stream, right? I was like, oh my
Hmm.
God, even things like this exist.
Yeah, I think maybe I just gotten used to it, and I would just say that like I'm just still like learning things out. But I think I get it. But like one part is just being familiar with it, and then from it just building onto it. Like if you tell me a new library, I should be able to figure it out much quickly. But I think at the same time I don't say that I know a lot of things. Like this LeRobot thing, I started maybe like this week only building all of this, and just had to figure it out on spot. So, but yeah,
I mean,
I think you'll be able to do it, man. Like I think there isn't the documentation is well enough. Just have to copy paste commands a lot of times. just have codecs in one terminal. Maybe chat
I
GPT or
have
something.
never opened a terminal in my entire life, dude. Come on. I'm that new to software region, so.
Yeah. No, it's a good time then.
So
Like I think you
if you
should.
point at a plane, Boeing, whatever, any train engine, you point at it, you tell me to CAD it out, all the engine
Yeah.
parts and everything. Dude, I will. But this is not my fault.
I can understand. I can understand. Yeah, but I'm telling you, like it shouldn't take that much time. Like probably like maybe get used to it. Maybe give like 2 hours or 1 hour to it. I think every day. Maybe by 1 week, I'm telling you, like
So
you'll be able to
I
catch up
mean,
with certain things.
let us just wait for the print to be complete because
Yeah.
I was very surprised when it broke. I was like, dude, I was just clamping it, bro. You don't have to be like that. And it's just
And what is the infill that
uh,
you're using for this robot? The robot?
30% here I'm using.
Okay.
See, infield does not matter very much. The walls they matter because all of the compressive load, so those that is on the walls.
Hmm. I think I got it printed from because I don't have a 3D printer. I got it printed from a website. I don't know. I think I used 20%, but it seems pretty sturdy. It seems pretty sturdy, matlab, to me at least for
See,
20%.
as I can see this one, this must have been on. See, it is very dense inside, right? So this must have been on around what, like even this the broken part itself is like quite. It has got quite weight to it. So I'll say this is around 50% infill. So I have done a lot of 3D printing. I don't know, I have done more than like uh, around 4,000, 5,000 hours of 3D printing I have done. I've even built 3D printers myself. So yeah, I'm pretty skilled there. But when it broke, I was pretty surprised that even with this much infill, this broke. I was just trying to clamp it, like
Did
just
you had motors
see
on
how
while
it
you
used to.
while you while you broke it?
Sorry?
Did you had motors on and everything?
No, no, no. I was just clamping it to, so that I can work on the upper assembly because it is hard
Right.
to hold and I just clamped it down and these 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 legs at the front they just exploded forward. I was like, what? For now, I'm just reprinting it on a higher infill. See, you can already see how dense this is than this.
You
So
you
yeah,
know what they
pretty
say.
dense.
Everything is a learning experience, so you shouldn't be disappointed.
It is. Everything is. So this is not the only things. We have also got VRs in the office. So yeah,
So your company that you're working on right now is working on educational robotics.
yeah.
Okay, and then you sort of experiment. Your job is sort of like experimenting with different robots, build your own robots, and just get a good
I mean,
documentation.
yeah. I mean, my job in particular is a lot more than that, but let's say that is a part of it.
Right. And how do you sell those educational services? What is it like? You help them set up
Okay,
robots, or like you
so
offer them consultants?
basically, uh, that is why I came here. So this company, they had great networks, right? So when I was working with in my company, and see, we had good designs, we had great designs, we had great rates. Okay, we were we were we agreed to a lot of terms of customer requests, very specific requests. We have no MOQs, no minimum order quantities. You want one, you get one. है You want multiple, you get multiple. And the rates are not very, high and low around that area. See, even after providing all of this, I was like, yeah, I'm not getting any orders, and why am I at loss? So networking is really important, and this company excels at it. So I'm here to learn
Cool, man.
about networking also, you can say.
Yeah. How do you think about the robotics scene in India? Like, because you're in the industry right now there, and you probably have
Oh,
talked to a lot of people.
see, it is going to boom. I have my friends abroad as well, and they're like, see, you know what? This this is not even booming in it. It is booming everywhere. See, now that we have got VLMs, so it is booming everywhere. Because it is very surprising when you look at the past that how we used to use computers, right? We used to use ChatGPT just to, just for our paragraphs and stuff. And right now, it has evolved to a level that, Claude can do every freaking thing from back end, front end. It can bloody do everything. So have you ever tried, using VLMs?
VLMs, मतलब VLMs or VLAs?
VLMs. So VLMs are basically visual language models, I guess. So, so you configure your
Yeah,
robots,
yeah.
right? So there is this URDF file, if you know.
Mhm.
So you configure your robots, you give it a video footage, and you just give prompts like you give prompts into any other, AI agent. You just give it prompts, and it will fulfill the task for you. So
So
have
any
you
codecs
seen?
can do that. Like
I mean,
if I
Codex,
give it a
yes, but
if I give it a design, it should be able to
you
make a URDF or something like that, pretty close. Or what about if I just like
know, but
prompt
like
engineer it and
running
like
them
work with
on
it?
local machines like NVIDIA and Jetson or like and stuff. Pi obviously very incapable, but like,
Yeah.
with
Okay, yeah, maybe
AJR
like
you can.
those frontier models. I don't know. Matlab, I have Jetson or an 8 GB, but
Mhm.
उसमें I'm able to run a VLM, but that was like 4 billion. It was able to do good tasks. Like I was able to give like multiple images and analyze it. Like for example, like if it is an image of all the rooms, 20 images, it's able to find all the objects in the images. So all those things it's able to do.
Yeah.
That too locally.
Mhm.
But if I want to make it more complicated, like make a URDF file and all, I think that's not capable of like maybe a local model at least.
Okay.
Yeah.
I mean, yeah, that that works, but like VMs, what I have seen, because I was on a call with my friend who's in Europe. He's in one of the best universities of Europe, and they're working with VLMs, and they had the same robot. That is why I asked my company to buy this. See, they had the same robot, and he just gave a simple prompt to pack his lunch, and the robot did the rest of the things. I was like, what? There's no way, man,
What is the
no
name of the
way.
company?
I was like,
Because that's what exactly I'm trying to do.
he is in Fontes, I guess.
What is the company does that or like he was working on
No,
this?
no, no. That it's his university.
Okay.
Fontes is in Europe and Dover.
Fontes University of Applied Sciences.
I think wait, just let me look it up. Fontes and Dover. It's in Netherlands.
Yeah, yeah.
Yeah, great university, man. They might not have it on the website or any other page, but like they were doing it because he just
Yeah.
video called me. They may not have updated it on the website, but yeah, they are doing
Yeah.
stuff.
If you find a video or something to send me, I mean, I'd love to see it.
Surely.
Yeah, yeah, yeah.
I'll send it on LinkedIn only.
Yeah, yeah, yeah. I can send you my number. You can just send me on there.
Surely.
Like, on, Yeah,
I'll drop mine on LinkedIn, right?
yes. Yeah, I think you've sent me a connection, right? So I think I should be able to do it.
Yeah.
Yeah, got it. Perfect. Thanks, man. I think
No worries, brother.
I'll actually, yeah, I'll actually stop the stream. I think you're also printing, but thanks for coming to the
Yes.
stream. Thanks for joining so long. Yeah,
No
uh,
worries. No worries.
I'm really good. Yes. Yeah, cool, man. Let's stay connected, and I'll probably make a video also for this, or maybe like I'll live stream tomorrow as well. Like I want to like make it pura agentic loop work on this SO-101. I'll see. I want to get the cameras actually because cameras near right now, but I'll probably try to source them by
See,
tomorrow. Let's
Ray,
see. Like,
what you can do? See, megapixels,
yeah.
they don't matter when it comes to stuff like this. You just need a good enough camera. You can blink it any webcam. You can get it around 600, 500 rupees, and you can get the tripod at the same rate. Even if you don't even need a tripod, you just buy a stand like this. See, this is a flexible stand. You can clamp it anywhere. Okay, and
Mm-hmm.
you mount your webcam here. Any webcam will work. Trust me, it does not
Okay.
have to be a Logitech or a 1080p version of it. You can have the local lab care ones and ones from Zebronics, and they'll also work. I mean, won't really matter. At least
Right.
you'll be able to get a better view out of it.
Yeah. I don't know because I think maybe some people were using one webcam as a third POV, and then there was one camera that was installed at the like Ripper. So usme I was thinking maybe add it, but I think you're right. Maybe let me just try with the webcam. I have a webcam already mounted on a
Okay,
tripod.
okay. So, like, do you have a phone?
Yeah. Please.
No, no, like a spare one.
Spare one. I mean, I can use like connect it to my laptop and like use that as a camera.
Okay. So, if you have a spare phone, you can use Droid Cam or whatever. So, I mean,
Yeah.
may be able to give you a far better, field of view and with depth and everything.
Right. Yeah, let me try that tomorrow. Let me try that tomorrow. And I
Surely.
was also looking at the, yeah, let me see if I can probably train something. That would be very cool. Because teleoperation, I was able to make it work today. It was not like once I was able to configure the motors. Now it was almost like I didn't expect it to happen so quickly, and it happened. The software is very good, like in LeRobot. So I think that after day operation, I would just like want to just train it now. So that would be interesting.
Yes. I'm glad you streamed. I got to found you. So,
No, same here,
yeah,
same here. Thanks for joining.
all this. So I'll be
Yes.
taking my
All
leave.
right.
Bye bye.
Yes.
Very
Yeah. Bye
late.
bye.
Bye.
Yes. Right. So I'll also stop the stream. And thanks guys for joining. If you're even watching this later, thanks for coming. And yeah, this was Lee Robot. And just to give you a final glimpse, so these are the two robots in my wave share. This is from the front. And this is the leader arm, this is the follower arm, and I think I'll come up with like maybe like more VLA trainings maybe tomorrow. But thanks for joining. Hope you have a nice day. Goodbye.